Okay, so today we're gonna do a review for like midterm 2 on next Tuesday, and the midterm 2 cover from the chain rule all the way to like linear to discriminant 10, which are like the linear approximation, and we start from the chain rule. So as what I would do, it is like the chain rule. We just define the derivative, and so now problem I'm working on it is the final exam. So we're gonna do the exam from the math department first, and then we would jump to Lawless archive, then we would jump to like other, just like other stuff. Yes. So much so if anybody can see his screen, and the problem, yeah. So the problem I'm going to, it is the fall 2019. It is fall 2019 final exam. Question 1. So going for this question, it's on the, so it's from like the final exam archive, and it's the fall 2019. So there are part A and part B. So just calculating the derivative of the functions. So for part 1A, so we use the product rule and chain rule. So, and here, and we use the chain rule again 2 times. And for first time, you like the inside function, 5x to the cubic square, and then plus sine of e to the times this is the inside function. And when you take the derivative of the 5x to the cubic plus sine to the e to the x, this is like another inside function. So when calculating, when find the g prime of x, and we just need to find this, and for this is like a 2 over x, and for this just do the product rule. Okay, so just going to go to autumn 2019. So this is like the problem that I'm just kind of working on. So you see chain rule and chain rule. So does anybody can see like his screen on like a fall 2019 final exam? So if you cannot see, please let me know. So are we going to move on to parts? So are we going to move on to question 1B, or you still need kind of me to elaborate more on 1A? Is any problem? Or we're good to go? Okay, so for part 1B, it's the same exam. Autumn 2019, winter 24, final exam. So we have f of x equal to 10 positive x to 2 cosine of x over x squared plus 1. And then for this one, we can just do as this is like a logarithm differentiation. There's going to be a quotient rule because we have a numerator and the denominator. So the tip is like when you have like a rational function, always just do like quotient rule unless it's a trig identity, unless it's like cosine x over unless it is like a trig identity, it can be rewrite to like another trig function. So are we good to move on to the next question? I think question number 2A, it is logarithm differentiation. Okay, so I will write down like into like a Google Doc, and when after the thing, then I'm just share the Google Doc and the recording on the Discord. I apologize again for the inconvenience, but I really want to help you guys. Check. Okay. So so first one gonna be fall 2019 is final exam. And then for problem 1A, is the chain rule twice and the product rule. For 1B, and what you have will be the available logarithm differentiation and the quotient rule. For question 2A, for question 2A, is what you can see here. It is, so it's a function to like a power to like function. So when you see like there's like function to the power of another function, always the logarithm differentiation. So it's like, so this can be logarithm differentiation. So like, for example, so like if you see a function, it is x to the power to the x, then use the logarithm differentiation, and then do not use the product rule or chain rule. Just use like a logarithm differentiation. But if you see function is like e to the power to the x squared plus 10, then it's the chain rule, and it has like 2x times the e, 2x times the e to 2x times the e times square plus 10. Well, if you have like a natural log inside of a function, for example, you have like a natural log inside of a 10x squared plus 10, and then you just do like 20x, then times the 1 over inside the function, then do the chain rule. So does it make more sense? So please give me like reaction if you think that what I say just make more sense, or do you need more kind of like elaboration?
Good luck.
Okay. So we're gonna move on to the next exams. So I'm gonna say So next exam, you're gonna and still just scroll down for fall 2019 exam. You know. Okay, so question number 6 on the same exam, fall 2019. It is same exam, is same. Yes, so I will go over like really rate problem right after like a parametric and the differentiation. So it's like, so the third problem from now will be like really rate problem. So about like 10 more minutes. So is that okay for you? Because I have to make sure that every topic has been go over in this review. Because like I just want to, you have just like it just like real for everything. So about 10 more minutes. So I need to go to do some parametric equation because this is kind of like another most because parametric equation is kind of a most annoying thing, but it is on exam, so let's do it. So number 6, so we have find the equation of a tangent line, so which is the derivative. And when you see a parametric equations, always just think it's a dy dx, and then you take the derivative of the y. So the dy dx, it is a y prime over x. So it's a y prime of t over x prime of t. Horizontal tangent line, and which is like a numerator, it is a 0. Because a tangent line, it is a horizontal when the derivative is a 0. And then we find the y prime of t, x prime of t. So for this time, we have dy dx, it is 6x 6t to the squared, and then we plus is like bottom is just 6t, and then we just radicate like the dy dx, it is t. So t it is dy dx equation, and we have a point is a 5 and 5 over 5. So the slope of tangent line is a 1. So 1 is the slope of tangent line, and then we have like a slope form for like tangent line, because tangent line it is like a linear equation. So you have y minus y1 equal to mx minus y. So we have like slope tangent form. So y minus y1, they equal to m times x minus x1. So we have y minus 5 equal to 1 times x minus 5. So y minus 6, it is the equation of a tangent line. So does this make sense? So please give me like reaction if you think that you understand, that you got it, or if you don't make much sense, please also let me know that I can explain more things. Okay, sounds good. Let me make sure I am recording. Okay. Okay, so question number 7 on the same exam. So it's like implicit differentiation. So this is the last problem before we jump into like the related rate problem. So this is gonna be the only problem for focusing on implicit differentiation, because what I perceive that the related rate is one of the most challenging, like the part of the exam. So I will spend about like an hour on it. So feel free to ask a lot of questions, because you know this part may be the most challenging part for many of you. So if you want to review more thing other than that, so please let me know that I have like a study guide available for you, and Yeah, I apologize for I can only do one implicit differentiation problem right now for today because I need to spend more time on related rate. Thank you so much. I hope you guys appreciate it. So let's start it. So I need to put in the chat. So for now, the question we are working on it is question number 7. This is fall 2019. Final exam, method 24. So this is the exam I'm currently working on. So we have this expression x to the cubic plus y to the 4 minus 6x to the squared minus 2x equal to a 0. Then the first part is find the dy dx. Then we need to do like the differentiation. So when you have any variables like their respective y, write dy dx out. So for this problem, you have x to the cubic, take the derivative, it's 8 to 3x to the squared plus 4y to the cubic dy dx minus 12x minus 12 equal to a 0. And then you move all the term that have dy dx to one side, and then keep the term without dy dx to another side. Then you will find a rational function that is dy dx. And then part B, find all the coordinate, all the point on the curve when the tangent line is a vertical. So horizontal tangent line is when the numerator is a 0. So for vertical tangent line, it is when the denominator is a 0. So for part B, just set the bottom of the function equal to a 0. And that's where you're going to go from. For part C, it is find all the coordinate where the tangent line is horizontal. So if you ever see a horizontal tangent line, always just to think that the numerator is a 0. So does this make more sense? And we're gonna jump into relative rate problem. So do you have any question on the ask on like the chain rule, implicit differentiation, or logarithm differentiation? So do you have any questions? Or are we all good? Yes, so we said the numerator is a 0 when you see a horizontal tangent line, but when you see a vertical tangent line, then it is the denominator. Yeah, so part C, so just to set that what you find in part A, dy dx is a rational function. So for part C, it is horizontal tangent line. So set dy dx equal to a 0, and which is the same as the numerator is a 0. Then you find the value. For part B, they're asking for vertical tangent line. So this means when the denominator is a 0. So does this make more sense to you? Okay, sounds great. Now let's do what Jenny wants me to do. It is really right, because I know this is most, I could say it's the most annoying problem. Yep, so it is annoying, but I'm so happy to help you guys. So let's start off like a problem. So it is so for this problem, it is departmental exam. So it is a math department. It's midterm 2. So midterm 2 archive. It is Perkins, the spring 2018. So it is this exam. So we're gonna work on question 5. Oh wait, I should put the chat error. I'm so sorry. I'm so sorry. I accidentally make this mistake, but I hope you can forgive me. Okay, let's back to the problem. So the length of the rectangle increases by 3 feet per minute, while the width decreases by 2 feet per minute. So for this, it's like become longer to longer, while it is shorter and shorter. So it's like, so you're stretching from like kind of like a square all the way just a horizontally stretching to like all to like a spaghetti. So you're from like kind of so you're just like stretching from like an index card to spaghetti noodle. So that is what you're doing. So when the length it is 15 feet and the width is 8 feet. So find what is the rate at which is changing. So part A is like, what is the area it is changing? So the area of a rectangle it is x and y, so which is the length times the width. And we take and now we have the equation that is A area equal to x to the y. And for this, we need to find what the rate of area is changing. So we need to find what's the dA dt when x equal to 15 and then y equals to 8. And we have a rectangle problem. So x it is a horizontal distance. So it is length, and the y it is a vertical distance, and then which is the width. And then we have a to the xy, and then we will have take the derivative. It is gonna be dA dt. It is x times dy dt plus x times y times dx dt. Do a product rule, and then first what we have it is the length. It is dx dt. It's a positive increasing, so dx dt is a positive 3, and dy dt is decreasing, so it is negative. So dy dt it is negative 2. So this problem for dA dt, it is x times dy dt plus y times dx dt. So x it is 15, dx dt it is negative. No, dx dt. No. Oh, I'm sorry. So x it is 15, right? Then dy dt it is negative 2, and then we have y it is 8, and dx dt it is for 3, and then we have a negative 30 plus 24. It is negative 6 feet square per minute, because area is feet per area is feet square, while one side is a feet. So does part A make sense to you? Sounds good. So for part B, it is parameters. So parameters, it is, yes, it is related to rate. So part B is parameter is all decided. Just so it's gonna be 2 width and 2 length. So it's gonna be 2x plus 2y. That is the parameter. So you have parameter m such as p. Now we need to find what's dp dt when the length and when like the side is decreased. Now we find this dp dt when the length is increasing while the width is decreasing. And then we have this p, it is 2x plus 2y. And we take the derivative dp dt, it is 2 dx dt plus 2 and plus 2 dy dt, because we take the derivative of each function. There's no product rule, no chain rule, no quotient rule. Just take the derivative. Make sure to implicitly differentiate the problem, because you need to put dx dt and dy dt into the equation. So now we have it's like a 2 and dx dt is 3, and then dy dt is -2, and then we have it is going to be 2 times 3, and we plus 2 times -2, so 6 minus 4 is 2. So the parameter, so like the whole line, it's like the so the parameter, it's just like if you put a fence in the outside of rectangle, so how much fence do you need? That's the parameter. The whole round of like the length of all sides, that's a parameter. So the parameter is increasing at a rate of 2 feet per minute. So if you get whatever rate is negative, then it is decreasing, or it's losing, or it's leaking. But if you get a rate is positive, then you're increasing or adding. And that is how the rate works. And then the length of the diagonal. So that's gonna be the right triangle, because okay, I need to check the Discord server so if there anything just popped up here. What? I was responding a chat. I'm back to the problem very soon, okay? Okay, back to the problem. So the enthalpy diagonal is the longest. So we have, perhaps we have x1. So this time the long side is going to be z. So the z, it's the hypotenuse of the right triangle. So we have z squared equal to x squared plus y squared. And the z itself, it is a square root of x squared plus y squared. Now it's the chain rule to take the derivative. It's a chain rule and the implicit. And then just put in like what they have is x and dx dt and dy dt. That is your answer. that the rate of change that how like length of the diagonal is changing when x is 15 and y is 8. So does this make more sense to you? So this is gonna be the entire problem for the first relative rate problem. Sounds good. So this is kind of like an easier one. So I would go with some harder one. So we have so that's 450. We end at 545. So I will spend the rest of the time on like relative rate. So if you have any other questions, please PM me on the Discord, and I will just make something afterward. Okay, let's back to it. Okay, this is a new problem. So now the problem we are focusing, it is still on the department archive. It's 28, so it is math department. It's midterm 2. It is Perkins. This time it's winter 2018. It is also relative rate. So this is the exam I'm gonna work on right now. So a flashlight, it is laying down the ground that 30 feet from the wall. It is on a point, it's straight at the wall. Isabel, it is walking straight from the wall to the flashlight at the constant speed of 3 feet per second. She's 6 foot tall. How fast is the length of her shadow on the wall increasing when she's 18 feet from the flashlight? So for this problem, it is a similar triangle. So we have the y be the length of her shadow on the wall, and this is the height. And the x is Isabel's distance from the flashlight. And then dxdt is negative 3 feet per. She's walking straight from the wall to the and to a flashlight. So she's moving from the east to the west. So it is decreasing. So x value it is decreasing. So dxdt is negative. And we need to find what is dy dt when x it is 18. So this is what we need to find. I have dxdt it is decreased. No, dxdt it is negative because she's moving toward the flashlight. So his x coordinate. So her x coordinate is it is decreasing, and that's why it is negative. And then similar triangle that 6 over x, it is y over 30. So similar triangle this time. And then we just compute the derivative. And then it is like d dt or 6 over x equal to d dt y over 30. Then we have to take the derivative of x, then we have negative 6 over x. Then we have it is like a negative 6 over x squared times dx dt equal to 1 over 30 dy dt, because there are two variables respecting y and respect to x. So, and then we have it is and then we put x and y, and then we plug in x and dx dt and define dy dt. So negative 6 over 18 to the square root times negative 3, it is 1 over 30 dy dt. Then we find dy dt. That is the rate when her shadow is changing. Does this make more sense to you? Or do you need more elaboration for this problem? Is everybody sounds great? Okay. So does anybody of you great to move on to the next question? So please give me reaction or put on the chat so I can have like kind of an idea on what to do next step. Hi, Mike. So do you want to say anything? Because I saw you're unmuted. So just feel to say anything because I'm open to everything. So ask me anything if you want to have something that I need to explain, or I'm going too fast, or I'm making some typo or mistake. So please let me know. Okay, so I would just assume Mike does not have a problem. Then we are moving on to the next next question. So we are from. So this time you can move to. This time we are doing like a Loveless exam archive. So we are doing exam from here. The link on the chat. So this is what we are gonna do from now. So now I'm doing it as the fall 20. Now it is now first, for example, we've been doing it as a winter 2017. And it's from Loveless. It is ready to write on problem 5. So the kite is in the air at an altitude of 400 feet and is being blown horizontally. So the kite is moving horizontal action, horizontal movement. So only x is changing. I apologize for yawning because I'm kind of like sleepy right now. I was doing my homework all day. I really apologize for it. I was doing homework for a long time. That's why I'm like this. But I would do my best. Okay, trust me. So, if a person holding the kite string ground level, so this kite is remaining. So the kite is remaining at a constant altitude of 100 feet. So the height it is not changing. So it keeps a 400 feet altitude. And then from what we know, it is dx dt. It is 10 feet per second. So dx dt is 10 positive 10. And then what part A we need to find it is what is the rate is the string being let out when 500 feet of string is already out. So we need to find what is dz dt when z is 500. So this is the right triangle. So we have x, y, and z. Y it is 400 because it's the height or so whatever. I'll just say height. So the height is 400 feet, and z is a 500. So x is a 300 by Pythagorean identity. And then we have the equation. It is x squared plus 400 squared equal to z squared. And then we do implicit differentiation, and then which is 2x dx dt equal to 2. I'm sorry. Equal to 2z dz dt, and then with z equals to 500. So I mean plugging x to 2x, it is x is 300 dx dt times 10. We have, and then we can do the equation easier because we can do x dx dt equal to z dz dt because 2 and 2 they can be canceled out. So 300 it is x, and dx dt is 10. The z it is 500. So we have 3000 it is 500 dz dt. The 6 it is dz dt. So this is when the rate is the string being let out when 500 feet of string is already out. So 6 it is rate of change. Well, that will virtually fine. So does this make more sense to you, or does anybody make sense to 5a? So do you need more elaboration to this problem? Okay. Let me make sure that you understand the problem. So the screen below is going to Is this really the right? Okay, so now we're gonna jump to fall 2017 as per request. So this back to Department Archive. Fall 2017. So it's question 5 or question 6. Okay, so I would just okay, I would do number 5 and number 6. Does it work for you? 5 and 6 all together. So it's more understanding. Okay, so number 5 is like a baseball diamond in a square. I think you probably see this almost the same problem when you're doing like website, but I'm gonna do this here again. Okay. So a baseball diamond in a square with a side of less than 90 feet. Kyle hits the ball and runs to toward the first space. So you start from the home, so which is like kind of the weight in the bottom, the corner, and then you're running upward this first base. So you have the same kind of a problem, or just do the exam or from like a website. So this very almost the same. At the instant, Kyle has to run for 30 feet. He's running 24 feet per second. At the same instant, there's another runner, Nelson, at the beginning of third base and home plate and running 20 feet per second toward home. At what rate is the distance between Nelson and Kyle changing at the instant? So it perhaps that when Kyle is running from home plate to the first base, it is X. And then the Nelson run from the third base to home base is just Y. This is another right triangle. And this is another right triangle here. And then we just to find dxdt is 24 because it's running outside is moving kind of x, it is increasing, and Nelson is negative dy dt is negative 20 because the y coordinate is decreasing. So the xdt is 24 when x equal to 30. And the y dt is 24 when y equals to 40. He's 40 feet from home. Then we define is dz dt when the hypotenuse is the rate of changing. Then we take the implicit differentiation 2x dx dt plus 2y dy dt equals to 2z dz dt. And then we have x dx dt plus y dy dt plus z dz dt. And then we put all x, y, z and dx and dy. Then you can find what is dz dt. So does number 5 make sense to you guys? Okay. Guys, so like I just feel so tired. So if it's okay if I end by 5:30 today, because I'm not sure I can last till 5:45. I apologize again. Because I know this is like a very this is a very because this is a very is this a very a stressful time of the quarter, and we all need to have some rest. So do you think it is okay if I end by 5:30 instead of 5:45? Because I normally want to end that early, but thank you so much for understanding. So we had 20 minutes, so it's like 3 to 4 more problem. So just to drop on the chat if you want to ask any kind of the problem. So before 5:30, I will do my best. And if I make any mistake, please remind me, okay? Because this is my first time I feel so fall asleep like 5 p.m. It's like I never had this before, but I don't know why this happened today. So a conical paper cup is 6 centimeters across the at the top had a height of 9 centimeters. So the 6, so we say across the top, it is the diameter. So the radius is 3 is radius, and 6 is diameter. Water is pouring into the cup at a rate of 3 cubic centimeters per second. So dV dt. So if you ever see like a cubic, then this is the volume. So dV dt is positive 3. And how fast the height of the water in the cup rising at the moment when it's 2 centimeters high. So we need to find what's the dH dt when h equal to 2. So this is what we need to find. The only variable we know it is dV dt. And first step is the equation of this. So this is circular cone. So it's more like an ice cream cone. So this is a circular cone. Oh, wait. Oh, geez, I forgot. I'm so sorry. So the volume of the cone is 1/3 pi r squared times theta h. And then we write like the equations like r/3 is equal to h over 9. So h is the third. So h is 3r. So we write this equation so like the inside of a radius, as though we have inside is like a inside a cone and then big cone. So like 3, it is the small, and then we have like the, and then h equal to 3r, because we only have pi and r's, and so we need to find dV dt. So we need to take the derivative of r. It's like the dt, it's related to dr dt. I apologize again. I didn't expect that. Okay, so v equals to 1/3 pi r squared times h. We have h like h is 3r. So v it is pi r to the cubic. Then you take the derivative dv dt is 3 pi r to the square dr dt. This 3 is dv dt. Then we have a 3. It is 3 pi 4/9, because like the height is 2 equal to 3r, so r is 2/3. So this is when the height is 2. And 3 times 4/9 dr dt. And then you have dr dt, this is 4/9. No, 9/4 pi. So 9/4 pi is dr dt. And then dh dt is 3 dr dt. And then dh dt is 27/4 pi. Like centimeters per second. So does this make more sense? After you derive v is 3 pi r squared. Okay, so like the right when the height is 2, so h is 2. And so did you have like notice the equation is like h equal to 3r. So set 2 equals to 3r. So 2 equals to h. H is just that 3r. Then r is 2 over 3. That is the r. And then plugging r squared, 2 over 3 plus 2 over 3 squared is 4 over 9. So does this make sense to you? Yeah. Okay. Okay, I think so. Does anyone want to go extra problem? Because otherwise, yeah, because otherwise it's gonna be the last problem I would go over because my brain is not in like a very good condition right now. So I may be not able to do like a hard problems, but I will write like a non-study guide when I feel energized again. I hope you guys appreciate it because I just have lots of homework. Okay, so like okay, so actually for now I probably just don't. Okay, so like I needed. Okay, so this is gonna be the last problem. So I maybe switch to like another different topic because I maybe switch to like I maybe do some like I maybe do some problem on linear approximation. Okay, so I'm gonna go over one problem on like linear approximation because this is also on the exam. Because I don't feel really good if I do like a hard relative rate problem, and I don't want to make like a tons of mistake here. So thank you so much. So I will do the last problem, which is like the related rate. Okay, let me find this linear approximation problem here. See if I can find it. Okay, so it's a problem 2 from Dr. Lovelace. So this is the last problem I'm working on. So this is a problem. This is the exam I am working on, and it's question 2 is linear approximation. So it's the last one. Use the linear approximation to f of x to the arctangent of 2x and plus natural log of 8x to the cubic at x equal to 1/2 to estimate what is f 0.51. So the linear relation Lx it is f prime of a times x minus a plus fa this is the linearization. So this is linear. This is linearization at x equal to a for f of x. Then we use the chain rule to take the derivative. It is arctangent of 2x, and then we take the derivative of one of natural log of 8x to the squared, and then what we need is f 1/2. It's a pi over 4, and compute f prime of 4, and then you find the linear approximation. When you find L of x, just put in x equal to 0.51, then that's just your answer. So does this make sense to you? Thank you so much. Okay, I think this is gonna be the last problem I'm working on. So here's some tip, because the midterm is on Tuesday, so I will not kind of have like review for tomorrow. Just get some rest, because like for tonight, I'm gonna post more a study guide if I have some, and post on Discord. So just feel free to check out. Because like I have lots of things to do tomorrow, and just take it easy. Don't be too stressed out, because I know week 8 it's kind of a very stressful time of the year, of the quarter. So don't be too hard on yourself. Just do some like review, and I will post the recording as soon as I have them. And I apologize again for all like the computer problem. I'm like fall asleep that thing. So it's like, so just one tip: just don't stay up late. I don't recommend to do that, because I really want to. I really go to bed right now, but I can't because I have homework to do. Yeah, I think. Yeah. I think I will probably end by now. So does anyone have any questions? Any questions before I leave? Because I need to. I need to get some Starbucks later. Because thank you so much. And like, so I'm just gonna end this recording, post on the Discord and YouTube channel tonight. So hope you guys have a wonderful night. Just because tomorrow your professor may do some like the review. Just go to lecture and just to listen to what the professor wanted to do on exam, because I don't know that how the professor going to write the midterm. So for any kind of other policies, just ask your professor, because like they know everything, right? Okay, sounds great. Have a great night. Bye, guys.